What we're doing is moving into circles, and the reason why we're doing this is circles involve square pieces, and quadratics had a lot of squaring to it. And all circles are is basically an application to the Pythagorean theorem. And so this is a picture of a circle. I think you can see right here. Maybe I should use a different color. The center is at 4, 2. Sometimes we even put a C in there for center. And then the R value is 5. So what they're trying to get you to do in this problem is to realize with this right triangle in here that this distance is the radius. And they ask you what x minus 4 is. Well, x minus 4, I'm going to put this in maybe this color, is representative of going to the right x units and then subtract off the center, the x coordinate of the center. So that is represented right here. So x minus 4 is what we call the bottom leg. Well, I mean, bottom isn't really a phrase that we use, but we definitely call the legs in a right triangle are the ones right next to the right angle. Maybe change colors one more time and talk about y minus 2. Where do we get that from? Well, y is going up that many units, and we're subtracting off the center, the y coordinate of the center. And in this problem, it is the, I'm going to call it the right leg, the leg that's on the right, where the R value is the hypotenuse. How do I want to phrase it? I've been using this color. I'm going to write it right here. R is the hypotenuse in the Pythagorean theorem. So what we can do is we could use the Pythagorean theorem and write the equation of this circle. And if you've forgotten the Pythagorean theorem, what it is one leg, so that would be the x minus 4, squared, switch colors, plus the other leg, so I'm going to do y minus 2 squared, needs to equal the hypotenuse, in this case is r, squared. And the only thing is we don't typically write the problem that way. Oh yeah, we do. I was thinking of the square root. I'm sorry about that. So what you should notice though is if we know the radius in the problem, which they told us the radius in the problem is going to be 5, and you can tell from the origin it's counting from the center we can count 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 down, 5 to the right, and 5 up. So you'd probably see me write this answer as 5 squared is 25. That's how I got that number. And I'm also going to point out that the 4 and the 2 come from the center. 4, 2 is the center in that problem. But we would probably write the problem this way. And so what we can do is we can show algebraically certain points are on the circle if we plug in 1 for x and -2 for y, we'll get a true statement. So what am I talking about is plug in 1 in for x in this equation and -2 in for y, and see, so here's my question, does it equal, so question mark, does it equal 25? So if you work it out, 1 minus 4 is -3, -2 minus 2, I don't know what's wrong with me, I wrote the wrong thing right there. I think because I underlined y, I just copied that down. That's -4. So that would be 9. -4 when you square it is 16. And yes, 9 plus 16 equals 25. So yes, 1, -2 is a point on the circle. And that works for all of these points. So as long as we know the center, h comma k, and we know the radius, we know the equation of a circle. And this is one of the times that the graphing calculator is not helpful. So if I follow my advice, the h value is -3 because it's the center, it's the x coordinate of the center. The k value is 6. And if r equals 3, I'm just thinking out loud, that means that r squared must equal 9. So you have to square each piece. And just a reminder that because the formula is minus h, it turns into x plus 3 squared. I don't know what I just did. And then y minus 6 squared is equal to 9, which is why my correct answer is option 2. And look at the other answers. They look pretty good. They just negated things here, but that's the wrong one because it's supposed to be x minus -3. So that's why it's the plus 3. And then these answers look good, except they didn't square the 3. You have to square the radius. That is part of your formula. So here's several problems. And all we're going to do is determine the center and the radius. And if the radius is not a perfect number, we're going to write it as a decimal, and we're just going to practice with a calculator. So remember the formula. I don't know if I need to rewrite it. Maybe I'll write it right here in case you can't see it on your page. And you would find this in like any math book. So the center, it's the opposite. So it is +2, +7. And pay close attention because they could easily switch x and y around. But it looks like all of these they actually put in the right order. And the r squared value is 100, so you'd have to square root to make r equal to 10. And you might want to hit pause on the video and just practice a few of these on your own. So the center here is 5. It's the negative of that, so -8. And the r value is the square root of 4. Because remember that equals r squared, so the radius is 2 on that one. Now this next one I think is meant to confuse you, but you're smart. You could have rewritten this problem as x minus 0, because subtracting 0 is not going to change the value of it. Y minus 0 squared, I'm going to sneak in 11 squared. I hope you know 11 squared is 121. So the center is at 0, 0, and the radius is 11. Just to work through some more. Again, you could probably hit pause on the video. Now this might trick you because r squared is 1, but 1 to the first power is still 1. So that's why the radius is the same numbers right there. We can sneak in a few different values. We can shift left and right 0 and then up 3 with a radius of 7. 7 squared is 49. And then the next one, I'm running out of colors to use, -6, 5. And this time, this will be the first one that we do not have a perfect square. I do like simplest radical form. Let me remind you on how to do simplest radical form, because you could rewrite this. The square root of 18 is the square root of 9 times the square root of 2. That is equal to the root 18. And so in simplest radical form, that would be 3 root 2. But because the problem just says nearest tenth, I would just go to a calculator and type in the square root of 18. And it's 4.2, rounded correctly. And yeah, I'm just going to quickly give you the rest of them. I don't know, the square root of 20. In simplest radical form, it would be 2 root 5, if you want to practice that skill. 4.5. And then this last one, square root of 57 is not a perfect number. I don't think you can break that down to anything, but I might be wrong on that. Square root 57 is 7.5. Nearest tenth. So that what we can do is we can actually look for intersection points. Well, I guess I'm getting ahead of myself. All they're asking you to do is write the equation of the circles, and we'll just start with circle A and then go on from there. Because in this problem, all you know, so let's do A first, that the center is located at 4, 1. We do not know R question mark, but we do know that we could rewrite our equation like this: x minus 4 squared plus y minus 1 squared is equal to r squared. And we also know this ordered pair is on the circle, so that means I could replace this problem with 6 for x and 4 for y, and leaving everything else alone, I can actually figure out what r squared is equal to. So here I would have 2 squared plus 3 squared. Well, 4 plus 9 is 13 equals r squared. So I can go back up to this problem and I can say that circle A then is this equation, x minus 4 squared. And that's the thing, is you don't want to square root this because we want r squared as part of our answer. And I can do the same thing for letter B. I'm going to circle B, and that center is at negative 2, 4. I'm going to go a little bit faster though. So we have x plus 2 squared and y minus 4 squared. But again, I don't know the radius, but I do know 1, 8 is an ordered pair. Well, 1 plus 2 is 3, and 8 minus 4 is 4. And 9 plus 16 is 25. So r squared must be equal to 25. So therefore, this final answer for circle B, we would just rewrite it this way. And then our last problem is getting us to practice a very probably the most difficult skill here, is to get it from this form into the form that we've been playing with to get the center and the radius. And it's going back to completing the square and that process. So what I like to do is just rewrite the problem with blanks in here. Equal to 10 with a blank and a blank. Because we've practiced this skill before where we took half of this number and squared it. So that would be 5 squared is 25. Now what's different with this problem, now I am going to put it right here, but instead of subtracting it later like I did in the previous section, I'm actually going to add it to the right side. And that is the same thing. It's okay to add here and add on the other side. So let me do the same thing. Negative 2 divided by 2 squared, that's negative 1 squared is 1. So got to add 1 here and add 1 here. So the reason why we go through all that is as I group the first 3 together, that is a perfect square trinomial. And we would write x plus 5 squared. Same thing with this middle piece. It's a perfect square trinomial. Y minus 1 squared. And as I put everything together on this side, 10 plus 25 is 35, plus 1 is 36. Well, look at that. It's in a very, very nice form where the center is negative 5, 1, and the radius, because remember this is r squared, has to be 6. And you should be ready for the homework now.